session on supply chain security. There is a delay in supply chain thanks to the pandemic and the disruptions, including, the moonlighting, working from home, the various geopolitical issues that are ongoing. But the good point is the previous panel, Mr. Prasad, was repeatedly focusing on supply chain issues and the importance. So essentially we are just continuing the session. So we are here having a excellent panelist who come from the diverse background that will throw some light on what are the real issues that we are looking at and what could be the potential way forward. Because if you look at any industry today, whether it is a product, service, solution, everything is smart with some software component in it. So any delay in it, my warehouse is going to be full with the item that is dumb without the smart thing inside. So any delay, whether it is development, testing, till it is released and it is part of the solution, we are going to have an economy that will be derailed. So it is extremely important that software supply chain is on track and it is not broken and there is no weak link. So how do we handle this? That is the key issue. So what we have here is, as you see, the best of the brains here. So maybe we'll start with CEO of Sakkaman, Nitesh Sinha, because he runs the entire company himself. So what is it that you are looking at to ensure that the supply chain is taken care across so that your deliveries are not impacted?
Sure. So my company works only with cybersecurity product companies. So we work with them to develop innovative cybersecurity products and solutions. I think the earlier session, the whole playbook magic, what you saw there, right? We developed the core components to it. So since we are in the product engineering space, is the whole software and supply chain cybersecurity becomes absolutely critical for us. So broadly, if you look at it, right, there are 4 risks associated to the software and supply chain security. The first one is the vulnerabilities. Vulnerabilities introduced when you're writing the code. The second part is the licenses there. The third thing is related to the third-party dependencies. And the fourth part is lack of procedures. If you don't have it and the processes, you will have big time issues there. So I think in terms of how we handle that is to address all these areas across the SDLC in that way, right? So right from defining the process and procedure, where I'm pretty sure all the enterprises would have those procedure, but I think to the extent of what is required from a supply chain security perspective, right? I think there's a long way to go. And there are standards which can address that. But I think at least having those vendor management policy, the license management issues there, the policies and procedures there, right? Is chain management, having a well-defined SDLC process is very critical there. When you are, writing that SRS or the PRD document for developing any of the component, right, I think you should look to leverage something called as the SPDX. So SPDX stands for the Software Packet Data Exchange. It's just for the information, it's a open standard to exchange the SBOM, what we are talking about, the software bill of material. And just for everyone to know possibly what is SBOM, right, I was just reading today, right, it's like when you buy any material, right, any food item there, the list of ingredients which goes on the back of it, right, which says that what goes into, right, and you decide whether it is good or bad. That is what SBOM is, right? So from a software perspective, it will exactly tell you what are the components there, what are the, the licenses which are getting used, what are the, the copyright stuff which are associated there, any of the software references. So all of these things is what goes into the SPDX. And it's a very, very, very well-defined standard we should start to adhere to, right? Is if you want to look at way to automate these things, again, from automation perspective, so that it streamlines things in that way. And then obviously, when you go to the design phases, you need to ensure and make it as a mandate that your vendor, if you're buying a product directly or your team itself, right, is when they're putting the design, They put the SPDX in clear terms that this is what we intend to use, these are the licenses, these are the dependencies and all that. And then obviously when you develop when we develop any of the products we leverage a lot of tools to ensure that, those issues are addressed, right? We are identifying and mitigating the issues related to, let's say, the vulnerabilities or the dependencies, what we would do it. And then of course the last part is, once we deploy it, we are continuously monitoring it. So I think that's a broader cycle and framework what we follow when it comes to the product engineering side of the supply chain security there.
So this is good. Just like a commodity, software development has become with a bill of material and everything like that. And this is maybe something kind of not very commonly used in many of the industries, because software is still developed as single piece with some plugins, rather than that product life cycle, or as they used to call software product chain, that modules you just integrate and go. That has not happened. But having done the job, still we have Amidst, who comes from Godrej and Boyce, and they are looking at as I said, they are a product and solutions company. In the end, unless the software element is put in it, the value addition is not complete to ship it to customer. So any delay is going to really impact the bottom line. So how do you take care of the software supply chain aspects, and how do you ensure that if there is a disruption to take care of the inventory and customer satisfaction and the timelines, how do you manage it?
Yeah, so I'll give a brief background what we do at Godrej and Boyce. So it's a conglomerate of 14 companies where we are manufacturing appliances, smart camera. Now we are moving into smart appliances like smart AC, smart fridge, etc. That is where you was talking about. So what happens when you look at smart, right? IoT comes into play, and when you are building a new feature, you are looking at the various features with the help of that what is the customer demand, right? And you know that what is the time to market. In this whole process, as he was talking about, the demand and supply, how to how to bridge this gap, because at times what will happen, there will be delay in development, and generally you find that the security testing, etc., takes a lot of time. That's why you see CI/CD, DevSecOps, etc., come into play, right? So in the whole process, how to ensure that right code is going to the production? What are the checks and balances you have in this entire supply chain? What is the time to market? What you promised to the customer, are you meeting that? If there is a vulnerability existing, or you have some kind of mechanism to monitor what is happening in your production environment from the software security perspective. If you are able to identify it at early stage, that's good, but that is the desired philosophy probably we do. That's why we talk about zero trust. In zero trust philosophy, probably in the supply chain also, a lot of people are thinking about how to ensure that continuous authentication, validation at every step, so that you know that what is going to the production is actually meant for the production, and nothing gone wrong into the production. What are the checks and balances you have from the start to end? And the fellow panelists were talking about the whole SDLC process. Those things need to looked at holistically, rather than you looking various steps, various things in blocks and isolation. That is where I think I had major challenge initially to solve these major problems at my organization. I think bringing a lot of teams together and making sure that they start thinking about security by design rather than security on bolt. That is the bigger problem we have today. Generally what happens, product is designed, developed, they come to security team and you do the assessment, and then you say, okay, these are the vulnerabilities you need to fix. And then they start creeping about it that security is getting delayed due to security testing. That is what people start thinking about it. Due to security, that the whole production gone live date has been delayed. You have to break that mindset. You have to tell them, if you do think about security by design, you follow certain security practices from day one of conceptualizing a product, conceptualizing a particular software, etc., probably your time to market will become faster automatically, because it will help developers, it will help security team, it will help production team, it will help everybody. And we as a security professional, we can ensure that, how to ensure that DevSecOps pipeline, CI/CD pipeline becomes what we want from the security perspective, and we can bring that checks and balances balances at every step of the SDLC life cycle. Thank you.
So thank you. So you can see even a non-core software development company is so meticulous about the supply chain from software perspective. This is something, you know, for everyone to see and learn. And David, they have mentioned he is coming from Saimru and he is the chief evangelist. So he evangelizes how, you know, these things to be adopted for the end users and the developers, everyone all alike. So they both have said from two different perspectives, one from a development, the other from the consumer perspective. But what do you preach when the audience is common and general purpose?
Thank you. So first, if I could frame what we do at Team Cymru, we are an intelligence provider. So we observe adversarial groups and we see the results of breaches. We see the activities that result in breaches and so on. So you could think of us as we are the people who observe the outcomes when software fails. You could think of it in this regard. And one of the things that we see as a pattern is, and one of the things, you know, we're talking about time to market is a development process. And in particular, in modern languages, it is very, very common to see code reuse. So, and what I mean is shared libraries, open source software, and things like that. And the challenge that we see a lot of people face is that as they're building their software, they're relying on software they didn't write. The software was written by somebody else entirely. So the challenge that you have is how do you have people who are able to audit this stuff? If they could have written it, you wouldn't need to borrow it, right? Or if they needed to get the product out so fast that they're borrowing all of the software, then the time isn't on their side to do that assessment. So a lot of what we do, to give you an idea, you know, we see like 700,000 pieces of malware every day, and we see you know 20,000 breaches or 20,000 command and control servers. Where, you know, we see bad guys in their native habitat, if you will, and a lot of the software development supply chain is these failings, like Log4j, we could use this for example, or OpenSSL has had a long history of these issues as well. Apache, much of their software has had these issues as well, and we're all reliant on these systems. So one of the things that I think is very critical for people to understand is when you're making the decision of, as we are developing our software, do we want to own the whole process? Do we want to sit down and then be able to code audit from beginning to end, or do we want to accept the risk and the reward being faster to market? Do we want to accept the risk of other people's code? And the challenge that we have there that we keep seeing over and over again is that unfortunately it's not very easy to ensure that these other people's code is effective. So a lot of what we do for evangelizing is to tell people, you know, you are working together to build your code, right? You're working together to use these shared libraries, to use these shared mechanisms, but we're not working together to secure them. For some reason, it's assumed someone else is going to do it. So bug reporting and things like that need to happen at a much greater scale. And you know, we're in it together. The internet is the largest social experiment ever conducted in mankind, really. And the frameworks that build it is all part of that. And that's a big piece of what we try to express to people, that, you know, working together, sharing intelligence, sharing understanding of vulnerabilities and things like that in more real time. So that's a lot of what we spend our time talking about.
Yeah, that's good. I think, you know, sharing of the vulnerabilities and sharing the lessons learned or lessons not learned, either way, that's extremely important to avoid, you know, costly mistakes being repeated. We don't have to reinvent the wheel. So we heard all those things. Now we have Vinod, who is a practice partner at Wipro. So end of the day, he has to put to practice with all kind of employees and different resources across whatever geographies and talent side and things like that. How do you ensure that, you know, people are actually able to practice what is being preached?
Absolutely, that's a great question, because, like, you know, the sources of like, you know, the code is, like, you know, quite diverse. In the sense, like, it consists of your proprietary code that you might actually write. There are certain dependencies that you could actually inherit. There are some third-party developers whom who actually write code for you. And then you also have SaaS implementations, and also cloud adoption, where you write certain functions. So let's see how this all came together, or where it all start from. If you just look back, SolarWinds is where it all started. Right? So there was a cast or a spotlight on what SBOM was, right? So that was a whole starting point. Nobody could actually trace, or it was already in there, but nobody knew it. So when the 0 day came out, nobody was able to trace back, saying okay, which are the applications that are actually using it, or where are the servers that actually have my packages. So that became fairly very, very difficult. If you again move back a little bit, because we all see, like my fellow panel said, there's time to market, there's no collaboration, because the nature of security testing which has been engaged with the development team is always cop outside the car. What that means is you engage fairly very late in the life cycle, right? So you perform some security code testing or dynamic assessments, throw out a 40-page document to the development team, and then say, hey, good luck, go ahead and fix it. It's your problem now, right? So rather than the model or the practices that we are actually looking at is, all right, so we may have to start developing a cop inside the car. What that means is start guiding the development teams by providing them appropriate requirements, because for, as Nitish said, writing an SRS, when you actually start off to inherit any dependencies, so there should be some key guidelines to adopt that particular dependencies. Today we are in a merger and acquisition spree, where you're actually acquiring a lot of softwares from other organizations, trying to onboard. So do we have a kind of a security guideline, except the fact that any critical or high vulnerability has to be remediated, right? So that becomes a kind of a basic rule. But these are the dependencies where you have a lot of exploits that are actually available. So the second point is about the visibility, right? So the first one was about the collaboration. Second is, do we have enough visibility to develop? All right, so these are my dependencies. These are the places that I'm actually using it. And then third point comes in, where is how do we, once you have a visibility and once we have a good collaboration, how do we develop automation in order to speed and do a time to market? This is the know-how, wherein where security just not running a tool, but building an engineering capability comes into a great view. And then finally, this actually leads to the transparency of security team and the development teams and the other teams, so that they can actually better collaborate and yield a better result. And then finally, accumulate all your vulnerabilities into a single space, because if you actually look at the security testing, most of it is all point-in-time solution. You have SCA, that is your software composition analysis. You have your static analysis. You have dynamic analysis, penetration testing, infrastructure vulnerability assessments. Now you have infrastructure as a code. If you see, none of the team talk to each other, right? So whatever that I would have done, or I would have actually missed in a static review, you don't even know that it has actually come in penetration testing. So hence, what we say is follow an application security orchestration and correlation engines, so you can actually adopt them, so that can actually give you a better SBOM driving the SBOM as such. So SPDX is one of, as Nitish said, SPDX is one of a framework, and that gets translated into an ASOC platform. That's it. Thank you.
Yes, so I think this is a very, very important concept as we look at it, because in any software development there are two aspects. One is the design aspect, then the coding aspect. At least the textbook says the coding effort cannot be more than 30%. 70% should be for the other activities of design and things put in place. So somehow with the CI/CD pipeline and agility coming in, while that aspect is being driven very fast from a CI/CD and continuous delivery perspective, the design part, the 70-30 concept, to what level are we adopting, is a major point to debate, because if the 70% is done right, probably the amount you have to write will come down because of the ability to reuse already available solutions that are already whitelisted rather than the other way. So that is one part. The second part is all of them mentioned how to plan and do it early. So there is a concept of, as they call, shift left. So don't test after the code is written. How much can we shift to the from a SRS to definition of the requirements and the traceability metrics and the coding guidelines before you compile itself, compiler does the job. I don't need a separate static analyzer post the writing of the code. It just like divide by zero error kind of thing. How many more things can be covered here? That kind of shift left becomes very important from a software supply chain risk management perspective. And that will also make software developers really a great developer rather than somebody who just programs. So that is important. Now you have mentioned this is what is possible. Maybe I'll go to Vinod again. How do you ensure that things are shifted left so that the issues are less?
Absolutely. So this is one of the teething problem that every organization has, right? To go to my previous point, what I was trying to say was your security requirements has to be so detailed. It should be very, very detailed. While you actually develop your engineering capability, you should start working with the development teams to write the blueprints along with them. A blueprint in the sense, a blueprint for your pipeline, a DevSecOps pipeline, or a blueprint for your infrastructure as a code, a blueprint for integrating your tools for dependencies. For example, are you actually pulling it from the right artifactory or not? So you actually define the blueprints, acceptable blueprints, mention the thresholds, the definition of a blueprint. You mention the thresholds because you can actually give some leeway to, possibly deviate, and then ensure you're complying to that particular blueprint. So this will actually ensure a standardization across the enterprise. You might use cloud, you might use on-prem, you might use SaaS platforms. Ensure the blueprints are engraved in the stone, so that they actually everybody adopts within the organization adopts to it. So, and then education is more important. In these days, if you see a lot of, at least we see this in financial sector and the retail sector across the globe. There's a concept called a BISO who has come into every business unit, a business information security officer, who's the flag bearer for that particular business unit to be security compliant, right? So that's one of the key KPI and KRA for this particular gentleman, who evangelizes this particular blueprint, educates the development teams, and he's also part of if you see now it's more on agile. So he gets engaged at the epic level or even a feasibility study level of your agile phase, right? So that he knows, he has an entire visibility, complete context of what that particular business unit does, where does it interface, and what's their pipeline actually looks like. Pipeline in the sense the pipeline of projects looks like. So based on that, he works with the security architect to get in the respective security requirements to be detailed for a particular sprint, and then ensure those security policies are actually applied. And when it comes to your automation is where I was talking about during when you actually use orchestrators, this is where you're going to measure with your compliance, and any compliance that it gets deviated, there are chances of even failing those builds as needed. Maybe we could be a little lenient with respect to a dev to test to stage, but not beyond that, right? So those are the practices that could actually come in very handy. And then finally your again, as I said, the ASOC platforms or engines become very, very useful so that you have a single unified view of all your vulnerabilities. And it is now these days the ASOC platforms comes with integration with your Jira system, that your bug tracking systems, your ServiceNow systems, so that you are able to not only help people identify vulnerabilities, but also fix them, track them, and then also give them contextualized contextualized view of what's the risk that an organization would actually carry if they are not going to fix it. See, this is where tools like Simru, come into a big play, wherein or threat intelligence feeds, right? So wherein we say, hey, this is already an exploitable vulnerability. You are actually using it, and also giving them a view of attackability and reachability. That's very key. What that means is, all right, so this is a vulnerability that you have. There are chances of attack. It doesn't mean if it is reachable, it is actually attackable, right? So if you actually give that particular metrics of attackability and reachability, so that gives more context to the developers and to the organizations to accept that particular risk or go ahead and remediate them. So these are various factors that we actually put in order to get things in order.
Yeah, I think it is good to see from directly going for hands-on, we are actually going back to the basics of theoretical computer science foundations, where we are looking at traceability, reachability, and safety properties, which are taught in original compiler design, formal methods, program analysis. So indirectly, what was considered too complex and theory is what we need to actually practice today to get it right. So maybe I'll go to David. When you have so much intelligence gathered, and then we have so much theory which is not practiced for whatever reasons, how do you come with a solution or preaching which will allow people to get it right first time, so that the output is right, it actually saves time instead of testing and reiteration and redevelopment. The less number of versions we have, the better chance that we are giving the right solution to the end user. So how do you preach this kind of aspect, having learned so much intelligence from your experience?
So, unfortunately, there's really no easy answer to what you've just described. All of us will make mistakes. That's guaranteed, and I can attest to that because we see the mistakes. Right. This is our core business is observation of kind of the internet ecosystem, and we are able to go back in time. Because we collect this data and we hold on to it for 90, 120 days, depending on the types of data types. And when we see, for example, SolarWinds, I think is a fine example of this. SolarWinds was a very typical, let's call it a typical nation state attack, right? They had gained access to critical systems, to the development process. They injected their capability, and it went out into the world. And that's something that the software developers probably could have considered. They should have operated their systems in a way with the idea that someone might want to come and attack us so that they can attack our customers. That should have been perhaps obvious. But there are other less obvious avenues, right? So let's say Log4j, right? Log4j wasn't a mistake. That was someone made a mistake and everyone was reliant on it, and no one knew that. There's no malice there. But there are other instances. So I mentioned OpenSSL earlier. It's widely believed that a Western government, potentially even the United States, had paid a developer to participate in the program, and purposely, so one of the developers whose names is right in the source code, so not even trying to hide that, and not a mistake, but they purposely injected weakness into some of the specific algorithms that were used. So that's something that as we are sitting out here making software, changing the world, making life easier for people, that development cycles, you have to consider these kind of, well, let's call them black swans, right? So once upon a time, everyone thought all swans were white. But then someone discovered a black swan and no one believed it because it was like, you would never imagine that such a thing could exist. But it's important for us, in particular, if you're the BISO, right? You understand your piece. You understand it better than the CISO. That's why they exist, right? But it's important to be thinking of these kind of outside scenarios. And I'm not talking about movie plots either. I'm talking about evidence-driven examples. And I've just given 3, that 2 of which fall into movie plots, right? So when we think of what could possibly happen, we have to really, really consider what things have we not considered? What movie plots could our situation find us in? Because what we see, so there are probably let's call it, in the millions. I think it's fair to say there are millions of software products in existence that are still maintained even. There have probably been tens of millions that have been abandoned, that are no longer maintained, but are still in use today, that are relied upon by the world for various functions. I mean, I've seen ATMs in the wild where they have crashed, and underneath was some variation of Windows 3.1. So we're talking like before NT kernel even. And so when you have this reality that the world is kind of running on pieces all put together, the software supply chain isn't just about development, but it's also about that interconnected ecosystem. And we see it exploited regularly. And oftentimes the methods being used, we see decades-old attacks still used, still work just fine, because there's no reason to invent the wheel. But what that means is that we, as the people who are making the software, who are making these capabilities, we have history to draw upon, because history is still present. Even though it was a 5-year-old exploit, it's still in use today. That means you can go read about 5 years ago. It's still available. There you can go see what had happened, how it happened, what mistakes were made, and we can be learning from that. So all of us, instead of focused entirely on the future, we have to kind of be thinking of our past. And I think that's a fairly succinct way to describe that. Thank you.
Yeah, so that's very, very nicely put, because we have a reasonably long experience in terms of timeline and enough history to pretty much take care of most of the issues that are seen on a day-to-day basis. Just that the lack of commitment to learn from what has already been gone through is probably the reason. But in the end, Amidst has to come up with something that can actually reach the market. So how do you plan in such a kind of a situation where we are not sure, there are risks involved? You plan your future releases because technology is changing. There are AI, ML, so many new things are coming. So how do you plan for a software supply chain which will add features to your smart solutions, that product that you are selling? So how do you plan it? How do you cover for the risk? And what ensures that the customer is happy and they're getting it on time?
Yeah. So I think the critical point you brought out is the shift left. That is the basic. If you are sticking to our basics, if your basics are strong, okay, so probably things may go wrong, but you will be able to come back to normalcy very quickly. You will be able to contain the damage to the maximum possible, whatever you can do. You talked about new releases and all. So we had a typical problem is that it's a 120-year-old company, right? And a lot of applications are developed long back, 60 years, 50 years, 30 years back, 20 years back. To cater for the new age requirement, you are getting into the new market, you are getting into the smart product where you know that features, you need to build the features as per the customer demand, as per the customer demand, you see where the market is moving, where the competition is moving. You need to build your application on new tech stack. That is, now, majority of the companies are moving into the cloud native apps, local platform, etc. So that you're developing a program or application or the new technology where the vulnerability, of course, is very less. And then you are able to integrate a lot of newest tools to understand your complete CI/CD pipeline, DevSecOps, and you have the right visibility. The key element in security is if you have the visibility, you can improve. If you don't have visibility, you cannot improve. That is the first thing. Second thing is, I personally believe awareness to the developer is the key. What we see, you need to understand what your developer does in day-to-day life. From where they take a code, how they use the code, do we have the blessed code, how do you ensure that blessed code is secure code, what kind of, I talked about zero trust, right? Authenticate, validate at every step. Do the developer know why we are doing it? It's important to take all the stakeholders onto a common platform so that they will understand why they are doing it. And then if you develop certain process and then you are seeing the trend, right? At the end, when the production ready application you have, you're doing testing, right? You get certain kind of vulnerability, which is found by your application security team, etc., right? Now, if you know the trend, what kind of vulnerability you are getting, right? you are improving your process on the left side. If you don't see that is improving, it means there is something broken from the design perspective, from the developer understanding perspective, from the coding perspective. I need to stitch this together. Until unless developer team, the managers, product managers, etc., they understand that whatever the application security guideline, awareness training to the developer, you are providing a platform for them to test, fail, test, try and keep testing so that your awareness is better. Until unless they are not understanding the importance of this, you'll keep doing the time and again same thing, and probably your time to go market will get delayed. And in that case, what we are talking about is probably if something has to go live, it has the vulnerability, somebody has to accept the risk. And that is not the right way of doing it. Because you might put the entire organization at stake, because one critical, somebody can accept the risk, right? If that get exploited, that can be intrude to the entire infrastructure. It's important to look at the key element in today's cybersecurity. You talk about holistically is the awareness. Awareness for the employees, users, developers, senior management, CEOs, board. Everyone need to know what is cybersecurity, and cybersecurity can affect each and everyone. That is what I believe. That is what I practice. That is what I have seen that it giving the result. I can see the if I stitch things together last 1.5 years, 2 years in my current organization, I see the declining, the kind of vulnerability we are getting at the end of the testing. It is declining, and we are getting a different kind of vulnerability. So that shows that it is giving us the fruit, but not that what we would like to see. So it's always probably you're always trying to improve the process. You're trying to understand what is your ecosystem, etc., and getting back to the basics, talking to the developer, what is your problem, etc., because they will have their own problems, right? So that is what I want to probably send a message across, is that awareness is the key. Thank you.
So thank you. I think, if you are aware, probably you know what you are doing. So at least the mistake by ignorance or by chance will be eliminated. So that is a huge chunk. Maybe Nitish, I have slightly different. He mentioned about the complete testing. In a hardware product, they have 48 hours of vibration testing. So many things they do. But today, as a software solution company, you are in a CI/CD pipeline where everything that is coded is immediately released. So how do you ensure that this kind of the thorough testing or validation happens, whereas today's requirement is the other end, instant release? So at Sakman, or as an individual, how do you handle this dichotomy, and what is the solution?
Yeah, sure. So I think awareness is definitely the key point which is brought up, right? But I think it's equally important for to provide the right tools at the right time for the developers and the testers, right? Across the SDLC, so that they are enabled in that way. Because many times there's only a certain limit to what human mind can really operate, right? But if the tools are there as an enabler and plugged in at the right time, it will help to fail. For example, I was talking about the SPDX, right? There were a time earlier where you did not have specific cybersecurity products on the supply chain security. Now you have evolving, well-funded products in the market space. Let's say where you can create SBOM using the SPDX format, right? Or during design phase, you can just upload your SBOM with the SPDX format, and it will exactly tell you that even before you write the lines of code, that these are your dependencies and these are your vulnerabilities there, right? At a coding, the moment your coding starts, more from a development for a developer, right, is you need to have your ID, integrated with a lot of these different products, right? Is where you integrate with the SAST product, and not just from what we have sort of got used to, right? You will find a lot of your IDs, let's say like a Eclipse, whatever you use, right, to integrate it with your SST product. But there are specific products on the cybersecurity, the supply chain security, right, which will tell you what are the, the reach vulnerabilities, what are the dependencies, and what are the known issues and the recommendations. So for example, you may have your Maven file where you define, okay, I will use this version of the library. But in real time, before it even goes live, right, there are tools now, if you integrate nicely, it will tell you that this is a vulnerable stuff and you need to upgrade it. So think of it as to what Amrish team, gets fired, right? It's too late in the game by the time it comes to them. But for the developer, if they have the tool to do it at the real integration, right, that's the key. Same thing when you are running the, checking the code, right, in the GitHub, the SCM products, right, is you can actually scan your, your code, the full code at time of the pull request. Similarly for testing, running it against your DST tool, your at times your CI/CD pipeline, right? You have the tools which can do the container level security scanning in that way, right? Your artifact scanning in that way. And then I finally think is you need to have a continuous monitoring stuff. So I think that last session it talks about more of integration with SIM, SOAR in that way. That will give you that ability to have a real-time detection response. So I think to automate this entire cycle, right, is with the right tools is the absolute key. Even if you look at your entire cybersecurity industry, right, every month you'll find at least 2 to 3 acquisition announcements which are getting done, because gone are the days where you say that I'm the best in, let's say CrowdStrike may claim that they're the best in EDR, but when they go to the customer they said, okay, you have it, right, but I have other ecosystem, network, application. So the product companies are forced to either acquire it or go through these integrations, right, or you build connectors in that way. And that is what is there was a time where there was SIM. Now you have SOAR. And if you think of it, is why that's the case is because SIM was just telling me the after facts, right, of how data is got logged. SOAR gives me an ability to act on the data in real time, and in one click I can block a device, isolate a network, do all of things. So it's all heading towards direction where you'll have fewer cybersecurity product companies, and it's all about integration and connectors, what we talk about there. So that I think will be the critical piece what we incorporate during product engineering.
Yeah, maybe I think the team has actually not only told how things are happening and how to practice and what is going to bring us. So we should actually summarize probably in one way, one in all and all in one. That is what we are talking about, the way AISS is planned. So many sessions, everything is covered in one way. Collaboration and trust is a key. I think DSC has done a great job of bringing it as a session. The panelist has given quite a great inputs. And maybe as a quick summary, what was told was, if I understood it right, to ensure that in the name of CA/CD or quick delivery, we don't compromise. Appropriate design, appropriate checkpoints, right from the day you take the requirements, so that only kind of completely validated, tested, vaulted piece is taken. Only the incrementally started, only that part is again integrated every release, so that time cycle does not actually negatively impact the quality. That is what is we are looking at it, and that will ensure the supply chain part of it. So with that, I will, before we close and thank the panelists for a great session, maybe one question or two maximum we can take, please.
My first question is David. So you were talking about the weaknesses that are getting induced into the code. My question is on if it is not a vulnerable weakness, we will not be able to detect it with the vulnerability scanning tools. In such a case, how do we detect such logically induced weaknesses, which may probably open up backdoors later when it is getting deployed?
So that is a very tricky situation, right? We have a need for developers right now that is far outpacing the available skills, right? We have people who are put in situations being asked to create things that they frankly don't actually conceive, right? So I think the challenge here, like, how do you prepare for this, right? It comes down to multiple pieces. First piece is your hiring process. As you're going to getting your talent, as you're picking up your talent, security needs to be part of your interview process. You need to not just hire people who know only so-called safe languages. That's, for starters, no such thing. So you can't just say, oh, well, we're using this language and it's safe, so we don't have to worry about that. That's nonsense. You have to sit down with the developers and you need to run them through these scenarios. Like if your application behaves this certain way, if you're allowing, so for example, I'm a C programmer, right? So I'm going to use a specific example, but if you say in your interview, what if you want to execute a text segment and turn it into a data segment? What risks could there be? And that person should have some answers for you. They shouldn't say, well, I don't know, I would look that up. Well, that's too late, because they're typing, they're creating something new. You can't look up what you are creating. It doesn't work this way. So to prepare, though, then you have to assume that the developers are going to fail. So, having people fuzz your software that didn't write it. So not the authors, but some other group. Ask someone to come and try to break it. We do it to networks and enterprises every day. We have red teamers, but we don't have people who sit down and attack the software stack. Not in the same way, not in the same voracity. So those two pieces, but then frankly, we also have to prepare for the failure. So write the code in a way that if it does collapse, you have a backup plan. You have an alternate way to do the mechanism. So what is the software designed to do? What are other ways we could do it in case this whale fails? What can we fall back on that doesn't change this? SolarWinds, for example, they were tanked because they had no other way to do their system management. Their code, this code was so embedded and had been there for so long, they had written things that hooked it, that other components were reliant on it. And that's a nightmare. So you need to have people who are, I hate to say it, but that are dangerous thinkers. Who can see these who think like, what would I do? And then they are the people who can see those things. But it's not an easy answer.
Maybe because it was in the please yourself. Yeah.
Short question. So between say SPDX and CycloneDX, is there one preferred method, or what have you seen?
I've mostly seen SPDX, at least few of the companies whom we work with, right, in the product team spaces, they are building their, the tools around that sort of standard in that way. So,
CycloneDX is the one which was developed as part of, along with collaboration with OWASP, and it's a kind of a commercial-led tool. But while SPDX is it's an open standard that can be adopted with the organizations, where you can interchange the thing between the organizations as well. For example, you have Godrej and Boyce, so there are a lot of subsidiaries under that, so which you can actually kind of transfer it. So that's the key thing.
Yeah, just a couple of more questions, but my thing is, having a CISOs always is a challenge. They can be called at any time, any moment. So Amber needs to go. So we'll formally wind up the session now. But we are available, so we can take the questions from you and you. So just after the session, we are still there. But we'll formally conclude. Thank you, DSA. Thank you, Manjesh. Thank you.